So the degree 3 or higher paper, here's some answers. Number 1, I took it easy on you. It had 3 hits, one of which is our favorite hit. What do you think there?
-3, -2, 1.
It is. So I gave you one with 1. How's it easy to spot 1 if I ever did that to you again?
Add up to.
If you just add up the numbers to start with, it adds up to 1, and then or adds up to 0, and then that factored real nice, and that's our hits. 2 has 3 nice hits, but not including a positive 1.
5, -1, 2.
It is. 5, -1, and 2. 3 has 3 nice hits.
2, you have 3 -4.
It is a 2, a 3, and -4. 4 has 3 nice hits.
2, -3, -1.
It is. 5 has 4 nice hits, including our best friend.
2, 1, -5, 3.
It is, yeah. 1, 2, 3, and -5. Anybody on the front have any troubles? On the back, quadratic puts in a much larger presence. There aren't quite as many whole number hits. There's a lot more quadraticizing. So 6 only had 1 hit and then some Rudy stuff. Or, no, what do you?
-3 and plus or minus root 2.
It is, -3, and then plus or minus root 2. 7 has 1 whole number hit, and then I's put in an appearance.
2, and then -3 plus or minus I root 15 over 2.
That's all true. 8 has 1 hit, and then a quadratic-y thing.
-3, and -2 plus or minus root 6.
That's true. Lucky duck, you got 4 nice hits.
2, 4, -3.
All true. 10 has 3 good hits, and then a quadratic I.
2, -3, -4. 3 plus or minus I root 7 over 2.
All true. Anybody need any advice? Seemed like that went a lot better than it did in Algebra 2. Is that fair? Yeah. You've gotten older and wiser in the last year, apparently. So, absolute value stuff. So, absolute value stuff is always double work. Why is absolute value stuff always double work?
Because you can have like multiple answers.
Yeah, how so? What causes that?
Like the bars make stuff that's negative positive.
Yeah, so if you put in a negative, out comes positive. And also, if you put in a positive, out comes positive. So there's usually a double way to put in numbers to make answers happen because 2 different paths converge into the same answer set. So before we do 1, let's think up a simpler one that's not on the page. Let's say if I just said to you that the absolute value of x was equal to 8, and there was nothing in the bars but an x. What's our double answer to that?
8 and -8.
8 and -8. So if we take that sort of mindset, what we need to do is turn 1 from being a single problem into a double problem. What double problem would we create on 1?
It equals -8.
Who equals -8?
Like the stuff in the bars equals -8.
Yeah, do we change the stuff in bars at all or just copy
No.
it? Just copy it. So one problem would be 2x plus 3 copied from the bars equals -8. Another problem would be
2x plus 3 equals 8.
2x plus 3 copied equals regular 8. And then we solve those and get 2 independent answers. So always copy what's in the bars, but let it equal 2 different things that are positive and negative versions, opposites of each other. Anybody want solutions?
5 over 2 and -11 over 2.
That's true. 5 over 2, -11 over 2. Let's skip down to 4, because that's the only other one with an equal sign. What's up with 4?
Impossible.
It is impossible. So sometimes it's double work. Sometimes it's no work. The bars can't equal a negative. So number 4, I set you up with bars equaling a negative, and that just can't happen. So you just put no answer and move on with your life. Question about equation stuff? I didn't do it here, and I won't do it on the homework either. But if there was other stuff involved other than bars, how would you solve that? Like if number 1 were like 6 plus 9 times those bars equals to 8, how would you approach that problem? Probably not. You'd have to do something first. If it were 6 plus 9 times the bars that we see that equal 8.
What is it, like parentheses? You like do it first and then
Not really. You'd have to get the bars
alone?
alone. So like if I said, instead of number 1, if I had 6 plus 9 times that bar set, you'd have to like add or subtract opposite first, multiply or divide opposite second. If the bars are in a collection of a bunch of mess surrounding it, you'd have to one step at a time do some opposites to get the bars aligned. Every problem on this, every problem on the homework, every problem we'll see together in this little seminar, the bars will be alone. But sometimes in the outside world, the bars have some muck next to them. You'd have to get the bars alone before we can create our like double-sided problem. Question about the equal part? All right, less thans. So let's talk about a simpler problem that's not on the paper. Let's just say the absolute value of x is less than 8. And we think about our number line, which we can't see on camera, but people at home can visualize a number line. If we tried to look on our number line, where is the absolute value less than 8?
It's between 8 and -8.
It's between 8 and -8. It's most of the stuff less than 8, but only to a certain point. As soon as we come down the number line left of -8, now the values are bigger than 8 were. So we have to stay between the 8s. So does anybody remember how to set up the problem that we're going to solve for 2?
-8 less than 2 plus 3 less than 10.
That's correct. I used to refer to this in our career together as a less than sandwich, you might remember. You might not remember that. But you'd be more likely to remember the less than sandwich than you would be to remember the term compound inequality or conjunction. I don't think you'd be likely to remember compound inequality or conjunction. Those are the two mathy technical names for that. But what I'm doing is what I call a less than sandwich. So you stick 2x plus 3 as where the meat goes in your sandwich, right in the middle. You surround that with a couple of less thans. Stick -8 on the left end as the number line sort of dictates. Put a +8 on the right end as the number line dictates. And then you solve it like an equation, just with a small technical difference. Equation solving, we always say we do the same thing to both sides. This, we do the same thing to 3 sides. This is like a 3-sided problem. So when we do an opposite, it's going to affect the middle zone where we're trying to eliminate a number, and then it affects both the right and left ends as you solve. Grand total on this? That's true. -11/2 less than x less than 5/2. Anybody need coaching on that one? Let's skip down to 5 because that's the only other one that has a less than in it.
Possible.
That is also impossible. We can't have for number 5 the absolute value be less than a negative. That can't be done. The bars would turn everything into being not negative, 0 and up. So can't do 5. So that's a nice easy one there. 3 is another type of compound inequality called a disjunction. You might vaguely remember graphing these. I'm not going to make you graph any of these, but if we did graph 2, you would have had a couple dots, and then what would you have done to the dots?
On opposite directions?
So,
When you go like opposite?
not for number 2.
Number 2 you'd go 2.
2 we would connect the dots. For 3 you'd get a
go
couple
away.
dots and we'd go away. Because let's think of a simpler problem than what I gave. If I just said the absolute value of x is more than 8, we could either be 8 and up or -8 and down. So this answer has to have the word or in it. We need to say this or that. There is a way we could have done number 2 to have the word and in it, but I never choose to do that. I choose to go less than sandwich. I think it's simpler. But for 3, there's no way around using the word or. So who or who would be your setup creation? It is. 2x plus 3 is greater than 8. Throw the word or in there. 2x plus 3 in there again, but less than and negative 8, we do change arounds on like everything basically. Instead of greater, we go less. Instead of positive, we go negative. And then each problem solves independently. Just make sure the word or makes it into your answer. Total solution.
X is greater than 5/2, or X is less than negative 11/2.
Yeah, since I did the same numbers every time in the problems, we got the same numbers every time in the answers. I don't think the worksheets for practice do that, but X greater than 5/2, the word or, and then X less than negative 11/2. Some other year, there might be a homework paper off of this that people would do, but our year, that's not happening because we're running out of days. So I'm cutting straight to the practice test for tomorrow, because then the final is the next day and we'll run out of school days. The last tidbit we have to do is 6, where I do another little bit of psychology. Anybody have a thought on 6 of the bars being greater than a negative?
Infinite.
That's true. There's a way to write the answer. Memories of that. What values of X would make that true? All of them. So you could, I guess, write a sentence that says something like every real answer is potentially an answer to this, or there's a symbol for such a thing. The counterpart to this means nobody works. Another symbol means literally everybody works. Anybody remember this symbol? It's a fancy R. So this means all the real numbers. So you do a double spoke down the left side of your R and then do a capital R on top of that. But that's a mathy symbol that means basically all real numbers. Literally everything could work there. So yeah, there is an infinite count of answers on that. That is true. Question about that at all?